Hello to everyone. See this problem. Here trace and determinant for a 2 by 2 matrix is given as -2 and -35. Then how to find the eigenvalues? So but here 2 by 2 matrix is not given here. But that matrix trace and determinant is given as -2 and -35 respectively. Now how can you find the eigenvalues? So first of all we need to recall the relation between trace, determinant with eigenvalues. How they are related to each other. So with the relation we can easily find that eigenvalues. So let's consider for this 2 by 2 matrix we know that there are two eigenvalues are there. So let's consider that is lambda 1 and lambda 2. So these are the two eigenvalues. Now how they are related with trace and determinant? What the relation is there? Trace is always related with eigenvalues, that is sum of the eigenvalues is always gives trace. Trace means sum of the diagonal elements. So that value is always equal to sum of the eigenvalues. Here total trace is given as -2. So -2 is equal to sum of the eigenvalues, that is lambda 1 plus lambda 2. So when you come to determinant and with the eigenvalues, the relation is the product of eigenvalues is always equal to det of that matrix. So that is lambda 1 into lambda 2 always gives det of that given matrix, that is given as -35. Now here let's consider this is equation 1 and this is equation 2. So from equation 2 we will get lambda 2 equal to -35 by lambda 1. Just I bring this term to the right hand side. So then I got the equation. So let's consider this is third equation. Now substitute this equation in the first equation. So then it becomes lambda 1 plus, in the place of lambda 2 I am going to write the third equation, that is lambda 2 value, that is -35 by lambda 1. So that is equal to -2. Now cross multiply here, then we get lambda 1 square -35 upon lambda 1 equal to -2. Now bring this lambda 1 to the right hand side, then we get lambda 1 square -35 equal to -2 lambda 1. Now bring this term to the LHS, then we get lambda 1 square plus 2 lambda 1 minus 35 equal to 0. Now it is in the form of quadratic equation. Now factorize it, then we get lambda 1 plus 7 into lambda 1 minus 5 equal to 0. So from this we get lambda 1 equal to, one value is -7, another one is 5. Now substitute lambda 1 is -7 or 5 in the third equation. Suppose if substitute lambda 1 equal to -7 here, it becomes, so it gives 5. Suppose if you take 5 here, by cancelling it we get -7. So 7 -7 comma 5 are the two required eigenvalues for the given matrix. So these are the required eigenvalues. And this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.